Hello friends, welcome to APM Stats Connect. Today we have a question from lifetime data analysis. The question is as follows. Suppose that in a laboratory experiment, 12 mice are exposed to carcinogens. The experimenter decides to terminate the study after 8 of the mice are dead and to sacrifice the remaining at that time. The survival time of 8 dead mice are 31, 58, 157, 185, 300, 470, 497 and 673. Assume that the failure of these mice follows an exponential distribution with mean theta. Estimate the maximum likelihood estimate of theta and 95% confidence interval for theta. So from the given question it is understood that the given sample is type 2 censored because the experimenter terminates the study after the death of 8 mice and then sacrifice the remaining at that time. The exact survival time of 8 dead mice is given in the question. So clearly the remaining 4 observations will be censored and is equal to 673 plus. And we assume that the failure of these mice follows an exponential distribution with the mean theta. So the density will be of the form 1 by theta e power minus x by theta. The question is to estimate the maximum likelihood estimate of theta and 95% confidence interval for theta. Now let's enter the data. We enter survival times as S time equal to survival times of 8 dead mice are given in the question, which are 31, 58, 157, 185, 300, 470, 497 and 673. The remaining 4 mice are sacrificed, therefore their survival times will be censored and is equal to 673 plus. Survival time of 12 mice is given as S time equal to C of 31, 58, 157, 185, 300, 470, 497, 673 and repetition of 673 for 4 times. Take capital T equal to sum of S time, that is the sum of total survival times, and R equal to the number of exact observation in the given sample, which is equal to 8. N is the size of the sample equal to 12. We have to find the maximum likelihood estimate of theta. The maximum likelihood estimate of theta is given by theta hat is equal to capital T divided by R. We have to find 95% confidence interval for theta. So we put alpha equal to 0.05. The confidence interval for theta is given as follows. The lower bound of the confidence interval is 2t divided by chi square with 1 minus alpha by 2 comma 2r, and the upper bound is 2t divided by chi square alpha by 2 comma 2r. So running the command LB, which is the lower bound, and UB is the upper bound of confidence interval of theta. We give C equals confidence interval Ci equal to C of LB comma UB. Now calling theta hat, we get the maximum likelihood estimate of theta, and calling Ci, we get the 95% confidence interval for theta. The estimate in the maximum likelihood estimate of theta is 632.875 hours, and 95% confidence interval for theta is 351.04 comma 1465.9. Thank you.